Gentlemen, thank you so much for joining me on the podcast. Really looking forward to it. Today, the co-founders of Natix. Are you guys each co-founders, actually?
So I am a co-founder. Ulrich is a very high-end advisor and hands-on building our automotive department, almost like a co-founder.
Oh, perfect. Well, appreciate you guys coming on. Really looking forward to this chat. We ultimately got connected, where was it? In South Korea, and nerded out over some food on what Natix was building, and I was impressed by kind of the depth of thought. So looking forward to diving into it today. Perhaps before diving a little bit deeper into Natix, can you each just do a quick background on yourself and how you ultimately got to this point in time?
Sure. So I will start and then I will pass it to Ulrich. So co-founder, CEO at Natix. Background, I studied wireless communication. So I worked on localization algorithms, location-enabled services, building maps essentially, or high-definition maps, local dynamic maps. During my R&D time, during my PhD time, I was actually working under the vertical of autonomous driving. That's how I met Ulrich. He had his own company, a lidar manufacturer, one of the leading lidar manufacturers actually. At the time, EBO. He came with this car. This is like back in 2013. He came with this car equipped with lidars. It was a Volkswagen, I think. And on our uni campus, it's going fully autonomous. And it blew my fuses. You know, at that time, it was like a sci-fi movie. And I was like, okay, this was before we actually started the R&D project together with Ulrich's company and my PhD work essentially. And fast forward, I started Natix 2020. We started working on computer vision AI on edge, so on device essentially, which is also privacy compliant. We sold it to cities, governments, businesses, different use cases, parking monitoring, crowd monitoring. And then 2 years later, we pivoted into Natix Network. And the realization was we realized camera is a super sensor, commonly available. That means it's cost efficient. And when you combine it with computer vision AI and compute capacity at edge, its powers are unparalleled. That's why, for example, Logan, your ex Tesla. That's why Tesla has been betting on camera as something that is scalable, at least today. And then we have other crazy sensors like lidar. I believe Ulrich also explained those. But it was a super sensor, and we said, okay, we want to build the largest camera infrastructure in the world without owning a single camera, the same way that Uber has the largest taxi network. And being familiar with deep-in model, it just was the was us Euclidean distance to do this the fastest and most efficient way. So we created the Helium for smart cameras, and the first application of that was obviously mapping. And today, actually, we're launching a new product, which we're even going for autonomous driving. But the flagship product that people know us with is the Drive-On app. It's a mobile driver companion app, smartphone app that you just download, put it on the dashboard of your car. You drive around. The AI is collecting what we call dynamic map information, like traffic signs, like fire hydrant, traffic lights, if there's an accident and so on. This information is broadcasted outside. You earn reward. It has navigation, dash cam, so a lot of utilities for the user. And we have a new product, which I would love to, I'll bring it up later when the time comes. But, with that said, I'll pass it to Ulrich. And yeah, Ulrich has been joining our company for, I would say more than half a year. And this new product that we actually build is a child of, both us and Ulrich, and a collaboration, because we didn't have to be very honest with you, the depth and knowledge that he has in the autonomous driving. So anyway, I leave it to him to also introduce and we can go further.
Yeah, Ali. Actually, I started my career in the German army, so I was an officer. If you do that in Germany, you have to study as well. So I studied mechanical engineering, but I was more on the software side. I did my PhD in cooperation with Audi and Volkswagen on collision avoidance of autonomous vehicles. Project, I learned, okay, LiDAR is important. So afterwards, I did IBEO. So we decided to work on LiDAR development for automotive applications. We started that company, and as part of this company, I also added a Bachelor of Business Administration at Switzerland and an Executive Master of Business Administration at University of Maryland in the US. Studies which I took in China. Afterwards, also doing some business in China. technical point of view, we developed LiDAR sensors. So if you see the Audi vehicles today in the front grille, the two black boxes, one is a LiDAR with the technology which was originally developed by IBEO. Later on, we also developed so-called solid-state LiDAR devices. In addition, we also developed all the software which is related to object recognition, environmental recognition, lane markings, whatever. And that was what Ali just referred to. We also used all this information to develop our own autonomous driving solution, but not to sell it, but to test our sensors in exactly the same environment as our customers would do it. Part of that, it was also necessary to think about validation of the sensor system, sensor fusion of all the algorithms. We recognized quite early that validation will be very expensive in terms of time and development costs. So I started a decade ago of a team which up with software solutions with a reference system, LiDAR-based reference system. We developed our own HD maps. We put in these maps all the trajectories of the road users. And so we developed algorithms to generate automatically ground truth information. Enabled us also to validate complete vehicles with a complex sensor setup in public traffic. Personally believe that today there is still too much time which is used in order to generate ground truth data, to collect all the data. This is exactly the idea of bringing together data collection, the community that Natix has developed, processing this data in a way that we can generate scenarios, which we could call ground truth scenarios, and can be used in any simulation environment in order to have, let's say, data which comes from public traffic. So it's real data, not generated manually or virtually or whatever, but the testing in the future, from my point of view, we can do environment based on real data from public traffic. That's exactly
It was both the first product.
Just fantastic working with Ali and team to make it come true.
Amazing. Well, appreciate the background context from you both. Definitely lots to dive in throughout the podcast. But maybe passing it back to you, Ali, I think the market today, especially if you're probably listening to this podcast, is fairly familiar with crypto, fairly familiar with decentralized physical infrastructure networks. Two probably the most well-known ones today are HiveMapper and also Helium. One of some of the first OG products really testing the bounds in this space. HiveMapper also focusing on outsourcing mapping data, but then also taking a kind of AI/approach as well. Maybe to start off the bat, how would you kind of view the differences between Natix aims to build and also what HiveMapper is aiming to build, and kind of delineating yourselves in the marketplace?
Yeah. So I think originally when we started, we were more focused on the dynamic layer of the information or dynamic layers of the maps. HiveMapper was mostly focusing on the static layer of the maps because originally their dashcam didn't even have on-device compute. I think the new ones will have. So by the way, as the time goes on, and I said this, if you look at the podcast like 1 or 2 years away, these differences in map making will fade away. But at the end of the day, this was one of the biggest differentiators, which we were focusing on dynamic map information. They were focusing on static map information. We had compute
For the
on device.
people are not as deep on the mapping terminology, what's the difference between static and dynamic in terms of how it relates to mapping?
Yeah. So, in the map making world, you have the base layer of the map, which shows you where the roads are, where the buildings are, where the landmarks are, and so on. And then on top of this, you have, sometimes over 2,000 layers of dynamic information. Traffic signs is one layer, weather is another layer, lights are another layer. You have inclination. All this is additional pieces of information, additional layers of information. And then the dynamicness of this information depends on what we call information decay rate. Actually, we were the first people, I think, who coined, dynamic maps. It was part of the EU projects. And then later on, it was also HD maps that came close to that, but they're very focused on, autonomous driving. But basically, the more dynamic that you go, the faster the information will decay. So the highest dynamic layer is all the traffic participants, right? Cars, bicycles, pedestrians, because they're moving every second, right? It's very difficult to catch that in real time. And for example, pothole is something in between. It's there, today. It's also probably there the week later. And traffic signs as well, for example, they do change. There's certain dynamicness to them, like speed limit signs, because they change because of construction on the road and so on. So when you focus on street level imagery, which means you collect images from the road and you have to ship these images to the cloud infrastructure and process them with AI to build those maps, it's more for static layers of the information because there's latency included, right? To send this information, process it, and so on. And when you can do on-device compute and capture, let's say, traffic signs in real time and broadcast that literally within seconds and update the map, this is, where we call dynamic map information collection.
And so, kind of pulling on that string a little bit more, you guys kind of took the separate paths from dynamic to static to begin with, but I think you kind of diverged even further, particularly around the hardware. Can you talk about that? Because in my mind, when I think about the two differences, this to me is also a really big component between the two of you.
Yeah. So by the time that this podcast will come out, people will know about our newest product. And this is basically something that has been, built together with Ulrich. We were always looking into, so the dream was always building a camera infrastructure, and camera, it comes in different shapes and forms, right? Smartphone was just the most scalable go-to-market for us, which numbers are approved for that. Yet the quality of the camera, so camera is extremely scalable, but we can go into other ways of data collection with higher fidelity, with higher data quality. So the newest product that we have built is also for drivers because we do have experience with that type of users. It's actually for cars. It's for us to tap into 360 camera of the Tesla. So something that neither smartphone can do. So this is like a disagreement between me and Ariel from Hivemapper. It's like dash cam versus the smartphones. But we can both agree that something that none of these can do is to collect 360 data. And the enrichment of the 360 data and what you can do with it, even in mapping, it's just different. You can use Gaussian splat and you can build these immersive metaverse-like environments. You can do a lot of really, really high-end stuff, but you also don't need to collect this data very frequently. So that's why, for example, Google cars can actually do this, or some larger mapping fleets and more advanced one can do this, but it's very expensive. And you don't need it every day, so to say, to update. And essentially, the newest product that we have is a little box. You plug it into your Tesla glove box. You open it, you plug the box in instead of the normal, memory stick that is there. You plug our box, and we access the 360 video footage of your Tesla. We collect this, and we use this both for high fidelity map making, but also for something far more interesting, I think, than map making, which is another big differentiator of between Natix and Hivemapper today. The other one is what we call scenario generation. I think Ulrich he talked about it very quickly about like referencing and validation. But essentially, if you are an autonomous driving company like Waymo, or you are a normal car manufacturer like Honda, and you want to build an autonomous driving functionality like lane change or automatic right turn, The only way that you can test this functionality before going production is either you build a car and you put it on the roads of Japan, UK, Germany, US, and you really test this, which is extremely expensive. It's not scalable, right? The other thing is to rely on simulation environments. So you basically try to replicate the car and the traffic behavior inside these game environment, game engines, simulation environments essentially, and see how that functionality, how that car with its sensors basically behave with all kinds of, they call it near misses, stupid behavior of traffic participants, right? And today, this process is very expensive and it's not very efficient. That's why, I would say it's not as easy to release safe autonomous driving functionality. So we have US on one hand where they just release it and they care about the legal consequences later. And then we have Europe on the other side of the spectrum where they're extremely careful with releasing something like that onto the road. But either way, you need this information. And what we do with the 360 imagery that we collect from the data from the cars is we essentially detect objects and their trajectories, and we put them into the simulation environment. So now we have these, let's say, replicas of the world with all the traffic participants in it and how they behave. And then we classify them into scenarios, which means, we break them down into right turn, left turn, lane change, and OEMs and autonomous driving companies, like let's say Waymo, they can just go and they're looking for, let's say, scenarios in New York, right turn scenarios in New York. They search and then they're going to find, 50 different ones with the metadata description of this. They can download it in their own format, put it into their own simulation environment, and test it out. Very, very efficient. So this is kind of the autonomous driving, which goes far beyond mapping with this 360 video data that we're playing.
Maybe to just reiterate it back to you and the audience, just so that they're following along, you would highlight the main differences between you and Hive Mapper really being around the hardware devices. You guys originally focusing on cameras. They had a kind of dedicated device that you had to buy and then purchase and put in the car. Really Natix focusing on the dynamic kind of mapping data. But what you have realized with this new device is really needs a lot of data. And if you can tap into that 360-degree camera, especially that Tesla has kind of pioneered some of their camera suites in their cars, that can be really useful to train large-scale neural networks and ultimately further us along in terms of generalized full autonomy.
Correct. And just to be clear, our strategy is still, borderless capital, coined this term commodity hardware. So if you think about it, we're still tapping into an existing device. By the way, we looked even into building a 360 camera and talk with some partners, and the retail price of that 360 device, let's say, so 4 cameras around, would have been, bill of material would have been, $2-3K. And then imagine, like we also have cost and distribution and so on. So it wouldn't have been very, very much scalable. And now with, a few $100s, we're tapping into something that worth, even from hardware point of view, a few $1,000s, and it's able to generate a data that no smartphone or no dash cam can generate, which is 360, not even pictures, video data, which can be used for, like you said, for building better ADAS stack.
And Ulrich, I'm curious what got you kind of excited about this vision. I think today in the autonomous landscapes, there's 2 really kind of schools of thought, so to speak. One around vision-only approach that kind of Tesla is taking, doing full end-to-end neural networks, and the other I would kind of put on the other side of the spectrum is add LiDAR, kind of do the Waymo approach, where you can get things down to the centimeter or even higher degrees of accuracy, geofence certain areas, and then let the cars go. What kind of about this Natix vision ultimately got you excited to kind of help the team along and felt like this was kind of the right approach?
So, first of all,
Push back on any of that if you disagree with it.
First of all, from an autonomously driving point of view, if you take the Tesla approach or if you take an approach with all the 3 different technologies, At the end of the day, you somehow need to test and to validate that the system does in public traffic what you expect. Personally, I'm convinced that three technologies do have advantages. So I had my own company with making LiDAR technology, so I'm definitely a LiDAR fan, no doubt about it. When it comes to validation, it is a different topic because validation requires ground truth data. To understand the truth first, and then any type of sensor fusion system, you take the ground truth information, and by comparing the two results, comes from the original setup, which is in mass production or will be in mass production of the vehicle, including all the sensor fusion. And the other one is the ground truth information, which has to be more accurate, more precise, to test the results and to validate the results and to figure out, okay, what are the limits of fusion system which will be in production or is in production. So, and in order to do that, you add, let's say, expensive measurement systems, usually LiDAR based, GPS, IMUs, and all the additional stuff, to a few test vehicles, and then you operate these test vehicles, you collect data, and then when you have done all this, you don't build up 100 vehicles because it's much too expensive. So you build up as an OEM just a few vehicles, and then it takes longer. It takes some months to collect the data. First point. So data collection time, which is crazy in development, slows down development significantly. Second point is this, the original approach, and this is the common approach today. You take this data and you have a lot of people which label this data. So they go frame by frame for any video image and they label the objects, they label the lane markings and so on. And that again takes a lot of time and is expensive. And the result is you have ground truth data, which means starting the first test ride, it takes 3 to 6 months or even more time. The data that you need to understand or to evaluate your own results of your own produced sensor fusion system, figure out, okay, where are the limits and performance. From my point of view, is get rid of that. Be faster. We have to reduce the costs. So, that was the basic idea. Can we make use of community of Natix data collection? And from my point of view, yes, do that. So that's the first step. And then if you do this, it comes to the second question. Okay, is it possible to take out from doing the ground truth data generation? Yes, absolutely, because we have done this in the past. There are some other companies in the market which can do this. It's the right time to come up with a new approach, an AI-based approach to provide this information. And if you put this together, start at any time with a vehicle that you want to develop, that you want to sell, that you want to equip with a certain ADAS application or level 3, level 4 application. And on the other hand, at the end of the day, you can also think about validating vehicle in a virtual environment. Do it today, and as we have done it in the past, based on real data from public traffic. Not collected anymore in the future by measurement vehicles, which are expensive, time-consuming, and so on. It's done scenarios which are generated in public traffic, and then you have the real environment, your vehicle in, and do the same tests as before in public traffic. But it's available all the results. You don't need to wait for the results. You know and understand all the environment perfectly from the simulated is originally a real scenario. It is not generated manually, whatever. It's taken from public traffic, transferred to the virtual environment, and then you can do everything with it. You can add rain and so on. You have all the fantastic advantages of a simulation environment available. And so for one single scenario where you collected the data in public traffic, you can generate hundreds or thousands in order to check your software on all different levels. Level, data level of sensors, you can check, can I see the objects? Then can I track the objects? Can I classify the objects? Can I correctly fuse the objects between the different sensors? Make use of this in order to have consistent description about the up to the driving strategies. You can test everything, and that's fascinating. So far, in order to coming to that point, it requires a lot of work, a lot of time in development. That's the point when, okay, together two worlds are so far not connected, and all the advantages.
It's definitely interesting hearing kind of the different approaches, but to your point, I think regardless of either path that you kind of choose, you still have to determine the ground truth. One thing that Elon used to say quite a bit when I was at Tesla is close the loop and then iterate quicker on that feedback loop and just make it turn faster. So I'm curious, this kind of overall structure and continuing to iterate on the product side, starting and continuing to kind of push forward the dynamic mapping, but also adding and kind of expanding the products suite to say, hey, there is this massive market out there around autonomous cars, and really what they're limited today is by data. And if we can go out and capture some of that real world data, we can get to the ground truth much quicker. How does, I guess, Natix plan to scale this new product suite to enough Teslas where you can collect enough data to actually go out into the market and say, hey, we have some really awesome data collections from these different Teslas, but now we want to go sell it to the real world?
So this is a go-to-market kind of thing, and we looked into it actually extensively from distribution point of view. Something that helps, I think, is Tesla is one of the few non-crypto products that has very strong community, because, community is everything in crypto, but not necessarily, in non-crypto. Like HubSpot doesn't have a community, right? But they have a good product. There is no community of people nerding out. Tesla is like that. So this makes our life a little bit easier to tap into these audiences. But one thing that I have always also said, Logan, is utility. Aside from token, which obviously it's a catalyst, is not the reason that people should buy your product. At least not in my school of thought. Utility is the most important thing, and for us, the utility here is the 360 video that we collect. You can actually store it on your basically personal cloud space, and you can access it anywhere, anytime, which is not a functionality that Tesla is providing at the moment. So yes, you can record your footages if you own a Tesla upon a certain incident happening. But let's say you're a fleet manager and you want to you want to record the entire trip of your entire Tesla fleet in case something can happen, at least for a period of 1 week or so. So, we are introducing this, let's say, cloud dashcam functionality with fleet management, which is going to be, I think, one of the, big utilities for the driver. Aside from that, we have same components from our Driven app, like Marketplace, which has, both, let's say it also brings non-crypto rewards into it. We're thinking of, putting something similar to what we did, for example, for navigation, but let's say along the lines of EV charging and things like that. So there's a lot of these other utilities that you can have for the Tesla drivers to actually buy your product and use it. Some of them are related to their own data, which creates a flywheel effect, in terms of drive, and the navigation uses the data that they collect to get better over time. So that is better utility in my opinion. Some of them are not. Like the simple dashcam functionality is just a simple utility that the user gets. So this is how we are looking at basically distributing this hardware and having a selling point for the end user.
Yeah, I'm very fascinated by this because I do think this is a huge untapped market more broadly. I've always thought this data collection on Tesla, it seems on the surface, at least to one that enjoys the kind of technology of autonomous cars and getting into the nitty-gritties from afar, that Tesla should win the generalized autonomy, but that feedback loop that they've created is very valuable, and that data moat is even much higher than most would kind of care to think. And so to me, it's really fascinating being able to tap into all the video and the data that the Tesla is producing to say, hey, this kind of generalized solution that Tesla is taking, we can take that data, iterate on that data, establish some ground truths to help other car manufacturers potentially speed up their autonomous driving kind of life cycle much quicker.
Yeah, and this is a drastic change, Logan. When we talk with like simulation companies right now, again, let me emphasize that if it wasn't for Ulrich, we would have not been able to build this. That's why he's not an advisor. He's like hands-on working with us on the project and what we're building. But, creating, let's say, those ground truths, those scenarios, takes experts right now these days to do it. And depending on the complexity of the scenario that they want to test the vehicle or ADAS functionality in, it's from few hours to few days of work, right? And this is like one right turn scenario, right? Like we were talking like one scenario and they want to test it in, a couple of hundred actually to really make sure that this is efficient. So you can imagine like how much this way of automating these ground truth or scenario generations would save, how much time and how much money it would save the autonomous driving companies or automotive, let's say, industry in general. And then on the side of the dream, by the way, there are still like NVIDIA is working on this. A lot of other companies are working on synthetic scenario generation, right? Or ground truth generation in that sense, or scenario is a better word in this case, where they use generative AI to create these, traffic models and how basically the different traffic participants are behaving, and then putting the car and the sensor in and testing all the functionalities. Essentially, even if that, I think we're a little like still at the R&D stage, but even if that happens, like we're talking with these guys, and data is still the input to this. So the more data that you have from the real world and how the traffic participants are behaving, the better your generative AI can create these, synthetic scenarios. And what is interesting here, that's why it's not like things that human or AI can generate based on logic, because we have a lot of what we call near misses. So let's say a pedestrian not walking properly on the zebra line, right? They just take a turn, or he's drunk, or he does something stupid, or a bicycle just doesn't behave the way that they should. And these are, let's say, the more attractive scenarios that Natix can capture from real world data, or Natix can feed into these synthetic or Gen AI scenario kind of technologies to generate, a much closer and wider range of, synthetic scenarios. And that's why I believe, it's just game changing at the end of the day. And Tesla is not the only car, by the way, that we are going to tap into. Like at the R&D stage, there are a couple of other car manufacturers, quite big ones, that we know that it's very easily integratable. Tesla was the market entry point for us, or is the market entry point for us, but the same box can eventually be just by slight integration, it can be connected with other car manufacturers too.
Do any other cars have 360 cameras integrated to them?
Yeah. I mean, today, BMWs, Mercedes-Benzes, a lot of cars actually have 360 camera, and some of them do have the optionality of us tapping into that. Some of them is more closed source. So it's a longer way. And, for crowdsourcing, obviously, we're going to start with, let's say, the ones that are open to tap into. They have a port that we can tap into. And yeah, eventually, I think there is a world that once we grow, and because automotive is the end user of the setup, they need it. Let's say, giving an example, Honda needs this to create their AD functionalities and to test it basically inside simulation environments. So, it's at their win if we can also integrate it, if we can also integrate and tap into their, data collection. But I think, to be very honest with you, I think that's like a 5 to 7 year projection. We're first going to start with things that are, let's say, open already, ports that are open already, and we can just, build a plug and play hardware.
Rich, I'm curious, since you've been in the field for so long and autonomous driving and kind of seeing the different progressions, what do you feel are the large bottlenecks kind of today to get us to generalize self-driving? Is it more data, just establishing these ground truths? Do we need better LiDAR, such as solid state? What's the missing bottleneck?
I think two aspects of software development on all different levels in sensor fusion, but ending up in driving strategies. And look at state-of-the-art vehicles, still a combination of different types of sensors. As an engineer, depending on some parameters like weather conditions, lighting conditions. In this situation, you prefer this sensor. In another situation, you prefer another sensor. So, what we need to have only 3 different types of technologies which convert to the same performance with respect to field of view, with respect to range, with respect to resolution, but with the specific advantages or disadvantages of each technology. If they are all, let's say, somehow comparable with the basic parameters, much more easily fuse the data just based on some much easier mathematical models. And this will enable us also from a safety point of view, a better understanding about the environment. That is, from my point of view, essential. But I wouldn't say we need to have better LiDARs or better radars or better video. I think we need to have, let's say, resolution and range into the scenarios that we want to target. And if we talk about autonomous driving, which is the top on our desk in order to solve it. But if we take specific scenarios, as mentioned, for example, a right turn, range is not most important, but you need to understand how it enters the road. You need to understand that a bicycle, for example, it's a red light and comes from the right side, and it might probably crash into your car. So these require technologies are related to that scenario of range and resolution. If we take companies like Waymo, we mentioned them before, well, they go for the challenge and really a big task to solve all the different scenarios with all the patients that you can expect in public traffic. From that point of view, that is definitely the biggest task. And you can see the sensors that they put on these vehicles today. It's more important to get the right data instead of, let's say, making sure that every sensor is invisible and is part of the overall design. Still, let's say, in development, even though these vehicles operate in public traffic. And from my point of view, also feel safe today in these vehicles because there is a lot of experience already available in these companies.
It's interesting kind of you mentioning the fusion stack because, and kind of bias a little bit towards Tesla here, just because that's where I spent some of my time. And Andre Pathy had a good talk about kind of software stack 1.0 versus software stack 2.0, and 2.0 stack was a neural network that was kind of being into the software 1.0 stack. And in the past, they used to have, I don't know how many cameras they have on their cars now, I think like 7 or 8. Each of those cameras ultimately had their own kind of unique view, or the car had 7 different inputs, and those were treated independently. And the goal over time was to make a neural network that could digest all those different inputs, and instead of viewing each as one individual, kind of make all those individual inputs one single input, and kind of making that, collapsing the 7 different or 8 different camera inputs, radar inputs, LiDAR inputs into one unified fusion stack. And it's just recently that they kind of push both city driving and highway driving to a single neural network stack. So it's a very exciting time in kind of the autonomous car driving space. I think most people, if they got in behind a Tesla or even in a Waymo, they'd be pleasantly surprised by the experience. And it's quickly sneaking up on, I would say, the general population.
Yeah, I think Ulrich also told me something on our team offsite in Lisbon. We were chatting. A recent Tesla accident happened. That's why I think sensor fusion is even more important, where the sunlight was coming in and it basically blocked the entire camera, because the camera and the neural system thought that it's just a blockage or a concrete or something in front of the car. It was a heartbreak and everyone died. Ulrich was telling me like this can never happen with or this can barely happen with a LiDAR. And that's the point, that I think every sensor has its own advantages and disadvantages. LiDAR is still too expensive, although I think Ulrich is advising another company which they're building a super scalable 3D state LiDAR. And at the end of the day, if you want to build something that can provide high quality service 24/7 across all conditions, across all environments, the key is sensor fusion, and fusing all these different sensors, also across the sensor types, right? Not just through the camera, as you said, but LiDAR and so on. Just LiDAR is a little bit expensive, or it was expensive when Tesla wanted to go live 5 years ago. So I think that's why they relied mostly on camera. But if LiDAR gets as cheap as camera, I don't see a reason, and Ulrich correct me, I don't see a reason for them not to even Tesla not to equip, Teslas with a few LiDARs.
I know they definitely, with 100% do LiDAR testing in their vehicles to kind of establish the ground truths, and fuse that with their neural networks during kind of the training of the neural network models. At least, again, going back to Andre's of his podcast, has said useful for training, but not necessary in production vehicles, at least 100% of them. And so, again, we'll see kind of how that nets out. I don't know. I'm, again, kind of biased towards the vision approach, but looks like at least Waymo has a very good product at the localized level. I'm curious, though, on wrapping it back to Natix and how this is ultimately going to affect what you guys do in the crypto space and the product itself. Ooh. And you guys kind of started as this dynamic mapping solution. Now you're expanding this to new hardware device that can tap into 360 cameras or just cameras in the vehicle. How would you communicate the product that Natix is trying to build to the broader audience for people that wanted the 1-minute pitch, the 30-second elevator pitch, to try to understand what you guys are doing here?
Somebody with community member just pitched me today something. I mean, I think it still needs massaging, but it was like your Tesla, your cameras, your crypto, or your data, your money, right? And it can go along those lines. But as I said, I think I have always put an emphasis on the utility for the user, and crypto is not utility, in my opinion. It's just a side benefit. So the way that we're kind of pushing it into the market, one of them is the utility that the app directly provides. And I think the fact that they are contributing in something grander, which is better maps, higher quality maps, as well as a much faster autonomous driving, development. Essentially, as you said, Elon was always saying, close the loop, and then they can just go back. This is exactly what this product is able to do, or at least contribute to. And I think a lot of people, especially a lot of Tesla drivers, they drive Tesla because they're just geeks and nerds like me, and we just love doing that kind of stuff. And it's the same kind of community that invests in stuff in Kickstarter, right? They're also geeks and nerds, but a bit, it's a bit of a different game. So it's not really like pre-launch kind of product. When you buy a Tesla, it's actually working, but a lot of them actually want to see that autonomy coming in a bigger scale. So I think this is also a big message that we want to get across. And yeah, that's kind of, when we started chatting with Ulrich as well, there was this world of crypto and this world of complete non-crypto, and what Ulrich, I think, was kind of hooked with was like what he basically realized was crazy was how crypto can build the networks and coordinate them super efficiently. And he saw basically this data gap and what a crypto incentivized data curation network can provide, which has been something that he has been trying to do for 10 years, with different sensors, with lidars. And I think, yeah, it's just going to drastically increase the speed that autonomous vehicles are going to be built, developed, tested, and released into production.
I'm excited for this world. I think AI and crypto are probably the most interesting things. Reason why I appreciate, I'd say, crypto a little bit more is just because you don't have to spend maybe $100 billion or $100 million on compute clusters to go out and do large-scale neural network trading. But it's really cool what you can do when you incentivize people with crypto and having these global coordination rails to contribute data. And to your point, Tesla has a lot of very excited fans that are willing to help experiment and definitely willing to try this out. Is there any details that you can share around specifics on price, when this will actually be live, if people want to actually buy this for the Tesla and start contributing to the Natix network and ultimately earning rewards?
Yeah. So I think things can change, right? From the time that we are recording this podcast until, the announcement as well as the delivery. But the current status is we want to make it accessible. So it's gonna, and it's gonna go in phases, essentially the hardware. So the first phase is going to start a little bit cheaper because we want to, build the network faster. It's going to be, if I'm not wrong, below $300. The basic hardware, which has, very large storage and some compute capabilities. And then it's going to go higher from there on in multiple phases. And the delivery of the hardware is expected to be end of March, early April. And actually the hardware is ready, so we don't have production issues at all. Hardware is rather ready much sooner. It's just building the software would take a little bit of more time, and we're still a small team, so you cannot compare us with companies like Waymo that they can build something super. I mean, they have the resources that we don't have. So a software component is something that is taking us a little bit time, and there is a lot of optimizations that we need to do, right? So collecting this video data has different requirements. It's big in size, so we're doing a lot of optimization in terms of what we collect, how we're transmitting, and this is based on the requirements that we're getting. So we do a lot of requirement engineering, but we get a lot of requirements both from mapping industry as well as the autonomous driving industry. So the good news is, I think almost from day one, we're going to have a couple of very large map makers, on board with us. So this is going to be something that we will announce as well soon, but it's in quite good talks, I would say. Again, because of the type of data that is being collected, and it's the same thing. We were chatting with a lot of these simulation companies or even autonomous driving companies because they need this data to be able to collect and build from day one something that they need. So we're very fortunate that we have Ulrich with 95% of the requirements because he has tried to build this. By the way, at the time of video, people don't know, but Ulrich had a mapping department. He had an autonomous driving department. So he knows all of these worlds very well because he was building a product for each one of them and then selling it to automotive. referencing departments, so all of this was even for scenario, basically simulation, sorry, not scenario, simulation environments. He had a department and a company that was doing that. So we get a lot of requirements already, but a lot of it is also, the last 5% fine tuning. It takes a little bit of.
Oh, it's an exciting field, and it looks like an exciting partnership between you guys as well, and making this happen. I think crypto incentives combined with doing things in the real world and these more broadly decentralized physical infrastructure networks are really just at the starting line in terms of what they're going to do and how people are incentivized to do things in the real world. I think make really cool products. And so I'm excited about what you guys are doing here. As we're kind of, I guess, wrapping up the podcast, is there any specifics that we haven't touched upon that you want to, or kind of dive deeper into any more niche topics as well?
I don't know, Logan, what you think, but in general, I think with Deepens, there are different value accrual mechanisms. And I think, that is also something interesting to talk in our approach, as well as the tokenomics design. It's just something I would love to get because I think we did talk about it actually in Korea when we were having dinner, but that is something just generally I would like to both get your input on it, as well as see, because we have a very unique approach, and I don't think any other project really did the exact same as us, right? There was this very generic model that was there, which was non-deepen, and then there was the Helium model with its own, but it was the first model that went out, right? So obviously it had flaws, but still it was revolutionary in terms of the business model. And then we tried to build something that is different than any of these, and I think that is something maybe we can talk about, just getting your input as well on how you see the tokenomics of Deepin's design these days.
Anything that you can share on the podcast today, or things that you can share down the line?
Yeah, so I think in general we have, the value accrual mechanism for us is, and a couple of other projects also do this, is buyback and burn, and also going towards a staker from the protocol revenue. That's the majority of it with that order. And I think this is quite important in Deepin models. Like I have seen also some models that they don't have as clear or as good of a value accrual. And of course, a lot of projects can also surf on, speculation and marketing and, having the top two VCs in terms of AUM on your cap table. And I do see that, right? There's nothing, that's also a way to go. But if you're looking at a long-term, essentially, plan, 5 to 10 years, and I genuinely believe, like every other industry, a lot of Deepins might fade away, but a lot of them that have good economic models, good unit economics, they are going to survive and they're going to scale big. But if they don't have right value accrual mechanisms, aside from speculation, we're not going to see much. And I'm not pointing any fingers, but I'm just saying, for us, this was one of the most important. Yes, as for news, we're going to do our actually second burn, because we're live with the token, not for a long time, since July this year. So we did the first burn, close our customer, we're doing the second burn, and, the numbers are going, up quite exponentially. And I think this is quite important for any Deepin projects that is trying to build something sustainable for the long run.
Helium was definitely a pioneer, and not that they got it correct by any means, but they enabled to see what the world was possible when you incentivize people with tokens. And now I think it's the broader job of the crypto community to figure out, how do we continue to iterate on that, whether it's the buyback and burn, how that US is also having some current politics and being a little bit more pro crypto, at least on the surface thus far, potentially revenue share. There's a bunch of different news that ultimately open up if the US kind of leans into crypto as the market expects them to. And so, yeah, definitely happy to elaborate on different feedbacks on the token, but I think you guys are very directionally in how you guys are thinking about this. And so it's exciting to see your guys' progress, exciting that tapping into car's data, being able to learn from that, continue to train neural networks to hopefully make the world a safer place, get everybody from point A to point B with less accidents. But in the meantime, also building the best mapping solution that you can. And people can still do that, just for my understanding, with their camera alone. And that's kind of part of Natix's unique value prop, correct?
Correct. And, a smartphone is not going to go anywhere, because a lot of people ask us, now that you're launching the Tesla hardware, would smartphone get less priority or go anywhere? By the way, if you look at very large crowdsourcing map company, the gurus of crowdsourced mapping, you can see that they have the entire stack, from smartphone to dash cam to 360 cameras. They have the entire stack, and each one of them has its own advantages and disadvantages. And I think there is a little bit of similarity between autonomous driving and this as well. The core is to do fusion, because each one of them can do good in certain places and can not perform very well and in certain other aspects. So we're still going to keep the smartphone. We signed our first customer for the smartphone data. There's no reason for us to kind of leave that. Yeah, I think in general, and you started actually your podcast with asking me, like, what is your difference with HiveMapper? And I think with this new product and the new direction that you're going, which is, basically scenario generation for autonomous driving, this would be one of the biggest differences. To the best of my knowledge, we're one of the first crypto companies or deep projects that is actually doing something around, autonomous driving, something directly helping autonomous driving, stack to develop faster, to develop more efficiently. And if you ask me, I would say this is, mapping people might hate me for saying this, but I think this is a bigger problem, and both in size and in challenge. And that's actually where I see DeepIn generating a multifold of value compared to mapping, because, crowdsourced mapping also is nothing new, right? Us and HiveMapper, we're nothing new. If you want to really look into the best crowdsourced mapping project, I would say, in the world, you have to check Graph, the Uber of Asia. These guys have the entire stack. They invested a lot of money. They're one of the best technologies that are doing that. And obviously, crypto would just make it faster. But in terms of technology, I would tell you they're one of the best crowdsourced mapping. But this autonomous driving problem is something very unique. I think is a new baby in DeepIn, in my opinion, and we might have a couple of other competitors as well. But this is definitely something that you cannot do with smartphone or touch. You just absolutely cannot do it. So yes, can we have competitors in this sense? Absolutely. But I think our cutting edge here is, I think if they have somebody like Ulrich as well in the game that is as advanced in knowing this world, because believe me, Logan, we were even talking with one of the biggest companies in ADAS, very large company, and they're actually owned by one of the largest chip manufacturers. These guys also do autonomous driving to the highest grade, I would say. They're very well known in the world. And when we told them about how we're doing, let's say, scenario generation and scenario classification, they basically were asking, like, how exactly do you do it? And Ulrich was explaining to them, like, this is our approach, without saying too much. And you could see that they're basically completely clueless. I mean, what was interesting is that Ulrich actually sponsored like 4 PhD students. This is like 5-6 years ago, just to do the scenario classification side of it, right? So we have the cookbook to do these things, and that's the defensibility that we have essentially for this product and for this direction, which is very exciting. So one, I think nobody has done this yet. And 2, I think we have a team that, it's defensible. It's not that easy to just say, okay, I'm just gonna, build the same, because hardware is not that difficult. I can tell you, this hardware is not the complex part of the story, nor the distribution. What you do with the data is the real core part of the story, and the knowledge that you need to actually build those scenarios.
Perfect. Well, perhaps we'll end it there. Gentlemen, I really appreciate each of your time and coming on the podcast, diving into what you guys are doing at Natix and also kind of the cutting edge of autonomous driving. So I really appreciate the time today, and I'm sure the listeners will thoroughly enjoy the podcast.